Hello my friends, myself Anjali Rochkari. I have presented my PPT on a random variables. Random variables contents are introduction, first, second, discrete random variables, third, continuous random variable, fourth, the expectation of a random variable, and fifth, the variance of the random variable. Then introduction. Then what is meant by a random variable? In the set theory, we are finding the outcomes of the experiment. There is only the variables are there, but random variables means assigning a numerical value to the outcomes of a particular experiment. Means here we are applying a real number to the outcomes of a random variable. Example is that suppose machine breakdowns are there. In machine breakdowns there are electrical, mechanical and misuse of the machines. There are the possibilities where the breakdowns occur. So sample space is S is equal to electrical, mechanical, misuse. Then each of these failure may be associated with a repair cost. The cost is 50, 200 and 350. This is the state space, means we are applying the value to the machine breakdowns, that is electrical, mechanical and misuse. The cost of random variable is 50, 200 and 30. This is the example of a random variable. There are two types of a random variable. First is a discrete random variable and second is a continuous random variable. First, discrete random variable. Discrete random variable means what? If it takes at most countably means many values, that is integers. So it is represented as x is equal to u of 1 comma 2 up to k. P of x is equal to I is equal to 1 by k. This is the discrete random variable which is shown in the diagram as 1 to k. The random variables are assigning a integer values which is shown in the diagram. Then probability mass function. This is the mass function, means what? The for each outcomes of a random experiment, we are assigning a real number that is given by the definition is a set of a probability value assigned to each of the values taken by a discrete random variable. This is nothing but the probability mass function, and it is denoted as p of x is equal to px of x is equal to p of x is equal to x. P of x is equal to x means what? X is the outcomes, we are applying a real number, that is x. X is equal to 1 to up to k. Probability of x is equal to xi is equal to pi. This is the probability mass function of a discrete random variable. Why probability mass function is used in the discrete random variable? In a discrete random variable, the values or outcomes are present at a discrete point. So the for each point we are applying a real number. Then properties of a probability mass functions are: probability of a x is always greater than or equal to 0, and second property is that summation of p of x is always equal to 1. When these two properties are satisfied, at that time the given function is a probability mass function. Then example is that suppose machine breakdown has a cost x as given in the table. In the table xi and pi are given, which has a xi is equal to 50, 200, 350, and pi, that is the probability mass function, is 0.3, 0.2 and 0.5, which is shown as in the diagram. For the first property, second property is that summation of a p of x is equal to 1. So when we are taking the summation of all these probability mass functions at xi, we get that 0.3 plus 0.2 plus 0.5 is equal to 1. So given function is a probability mass function, and it is shown in the diagram. Then next one is the community distribution function. Why distribution function is used? When we have to calculate the value for a limited point. At that time the community distribution function is used, and it is given by f of x is equal to p of x is less than or equal to x. When we have to calculate the value less than x, at that time the community distribution function is used. F of x is equal to summation of y at y is less than or equal to x, p of x is equal to y. The community distribution function is shown in the diagram as like this one. Then distribution function properties for a discrete random variable is p of x is f of x is 0 when x is minus infinity. When x is equal to plus infinity, at that time f of x is equal to 1, that is community distribution function is 1. This property is applicable In the numerical, f of x is equal to non-decreasing function, means what? X1 is less than x2, then at that time the f of x1, that is distribution function of x1, is always less than or equal to distribution function of x2. Then f of x is a right continuous, means what? When f of x is equal is tends to f of x0, when x tends to x0 or x is greater than the x0. This is the property of a commutative distribution function of a discrete random variable. Then example, in the above example we are taking that the machine breakdown. Suppose we have to find the probability mass or cumulative distribution function of x in between the minus infinity to plus in between the minus infinity and 50. At that time we know that the first property is that for x tends to minus infinity, at that time distribution function is 0. When minus infinity less than x is less than 50, at that time the cumulative distribution function is 0. When 50 to 200, the cumulative distribution function which is given in the table, that is 50 to 200, the distribution function is 0.3. Similarly for 350 is less than equal to x is less than equal to infinity. Here when x tends to infinity, at that time the cumulative distribution function is always 1, which is given in the property number second of a cumulative distribution function. The next one, continuous random variable. Continuous random variable means here we are applying the range of the real number to the outcomes of an experiment. Here continuous random variable is defined by a probability density function which is given by probabilistic properties of a continuous random variable, which is f of x is always greater than or equal to 0, and it is given by integration state space f of x dx is equal to 1. Properties of this one is f of x is greater than or equal to 0, and second property integration from minus infinity to plus infinity, f of x dx is equal to 1. Example of a continuous random variable, suppose that the diameter of a metal cylinder has a PDF. F of x is equal to 1.5 minus 6 of x minus 50.2 square is equal to, when x is in between the 49.5 and 50.1. When here x is given in the range of a 49.5 and 50.5, so this is called as a continuous random variable. In a discrete random variable there is a real numbers are given in the, that is the integer values are given, but in a continuous random variable the range is given. So f of x is equal to 0 elsewhere. Beyond this one range 49.5 and 50.5, the f of x, that is a density function, is always 0. And the solution for this one is, we know that the property integration from minus infinity to plus infinity, f of x dx is equal to 1. At that time we use, by using this property integration from 49.5 to 50, the given function, that is a 1.5 minus 6 into x minus 50.0 d square dx is equal to, when we are taking the integration of this one, we get that is equal to 1. So given function is the probability density function. The probability that a metal cylinder has a diameter between the 49.8 and 50.1 mm can be calculated to be, this is the probability that the cylinder diameter is in between the 49.8 and 50.1. By taking the integration we get the diameter is 4.32, which is shown in the diagram. Then cumulative distribution function of a continuous random variable has f of x is equal to p of x is less than or equal to x is equal to integration from a minus infinity to minus infinity to x, means here the limited value of x is given up to which we have to find the distribution function of a continuous random variable, that is f of y into dy. Second property is f of x is equal to, that is the density function is equal to, it is the derivative of a cumulative distribution function d of f of x upon dx. Then third property is probability of a is less than x is less than equal to b. At that time the probability of x is less than equal to b minus probability of x is less than equal to a, that is probability density distribution function of a b minus probability distribution function of a. From this we get that when x is in between the a and b, at that time the probability distribution function of a b minus probability distribution function of a, this is the property. Then in the above example we have to find the community distribution function as f of x is equal to f of p of x is less than or equal to x is equal to integration from. Here we have to find the value from 49.5 to x is less than the 50.5, and it is given by 1.5 into minus x into y 50 square dy. When we are taking the integration of this one, we get the value 0.395. This is the probability community distribution function of a continuous random variable. In this diagram we are taking the probability density function as well as the probability community distribution function of a continuous random variable. This is all about the types of the continuous random variable, that is distribution and the continuous random variable. Then fourth point is the expectation of a random variable. Expectation means what the expected value of a random variable is called as the mean of the random variable. Means here we are taking the mean of the all the possible values of the outcomes of a random experiment. It is called as the expectation of a random variable. There is a expectation of a discrete random variable with probability mass function is p of x is equal to xi is equal to pi, that is e of x, that is expectation of a x is equal to summation of probability mass function of a x into the random discrete random variable xi. Expectation of a continuous random variable with probability mass density function is f of x is equal to the continuous random expectation of a continuous random variable is equal to integration state space x into f of x dx. We are taking here the random variable and the probability density function of a x. The mean of this one is nothing but the mean of expectation of a continuous random variable. This is the property of a expectation, that is e of summation of I alpha x is equal to summation of I alpha I e xi when I is equal to 1 to n. And second property is that if xi is equal to that is I is equal to 1 to n are independent, at that time e of pi I xi is equal to pi I e into xi. This is the important property of expectations. Then variance of a random variable. The variance of a random variable means what? It is denoted by the sigma square, a positive quantity that measures the spread of the distribution of a random variable about its mean value. The larger value of the variance indicate that the distribution is more spread out. Definition of a variance is given by variance of x is equal to e of x minus e of x whole bracket square, that is e of x square minus e of x whole bracket square. The standard deviation, the positive square root of the variance denoted by the sigma. The standard deviation is nothing but the square root of the variance, that is called as the standard deviation. The definition of a variance is derived as like this one: variance of x is equal to e of bracket of x minus e of x whole bracket square. Here we get the e of x square minus e of x square. This is all about the random variables. In this random variable, the types are the continuous random variable and the discrete random variable, and we are studying that mean of the random variable and the variance of the random variable. Then thank you.